Okay, so let's look at 1-6 linear systems. So our objective today is to use a variety of tools to solve systems of linear equations and inequalities. So what is a system of linear equations? Well, a system of equations is more than one equation, and we're trying to figure out what points they have in common, so where they intersect. A system of linear equations means we have more than one line that we're trying to figure out where they cross. So that's what a system of linear equations is. More than one line. Looking for intersection. So here's the thing, when we're looking for intersection, we could intersection points. We could have on a linear system, if we have two linear equations, they could intersect one time, and that would give us an ordered pair, like x, y. They cross, so it looks something like that, right? They cross, yay, crossing. All right, they could cross 0 times, so no solution. You probably remember this from Algebra 1. And the only way they will cross 0 times is if they're parallel to each other. So they have the same slope. Oh, I don't know what that is, but okay. So same slope. And then the third case would be all the time, like infinite solutions, and that's when the line is the same. So same slope, same y-intercept. I guess we could have written this in this space over here. All right, so a solution to a system satisfies, it's a point that satisfies all equations. So a point or points that satisfy or satisfies all equations. Okay, so when we have just a system of two equations, we're either going to have one point of intersection, no points of intersection, or infinitely many points of intersection. All right, so what are some ways we can solve systems of equations from Algebra 1? So this is throwback just a little bit. What are some ways that we could solve? We can graph. Not super accurate when you're graphing by hand. We can do substitution method. Or we can do the elimination method. And our job this year is to do what's the fastest. All right, we want to become super efficient in things that we learned in Algebra 1 and that we are repeating or revisiting this year. All right, so this is one of those things. So I glance at my equations and I'm noticing like this is solved for y, or we can solve this for y pretty quickly. I can move the 2x over and we can do the substitution method, right? The other thing I'm noticing is I could reorder these so I have the 6x in the front, and I could multiply the top equation by -5y and use the elimination method. And I'm here to tell you it doesn't matter. It's really personal preference, what you like the best. But before we do that, I'm going to graph them, and we are going to pick out the point of intersection so we know what we're getting ourselves into here. All right, so 2x plus y equals 1. That's what I'm seeing there. I just want to make sure I have the same thing. Yep. And 5y minus 6x equals 7. All right, so I'm going to go over here to Desmos, so I'm going to click on this point. So negative 0.125 and 1.25. So negative 0.125 for the x and 1.25 for the y. So I have solved the system by graphing. I know that's the intersection point, but we're going to pick out one of these two ways and go ahead and solve. So I'm going to do the elimination method. So I'm going to put this in a different order. I'm going to leave the first equation like it is, 2x plus y equals 1, And I'm going to reorder the second one so that my x's are underneath my x's and my y's are underneath my y's. All right, so I'm going to move the negative 6x, take the sign that's in front of the number, plus y equals 7. And the goal of the elimination game is to eliminate either x or y. And I do that by the numbers in front of the variable being the same number but opposite signs. So on the top equation, I'm going to multiply the top equation by negative 5 because negative 5y plus 5y will give me 0. And you did this in Algebra 1. I know it's been a little fat minute. But make sure you multiply everything by negative 5. So this becomes negative 10x because that's a 2 with a hat on it. So negative 10x plus a negative 5y, or you can just write minus 5y, equals negative 5. And then I'm going to rewrite my other equation, negative 6x plus 5y equals 7. And then I'm going to add these equations. So negative 16x, this is 0, negative 5y and 5y, equals negative 5 plus 7 is 2. So x equals 2 over negative 16, or negative 1 over 8. We can use our calculator if we don't recognize that fraction, but that is 1 and 25. Sorry, 100 and what am I saying? 0.125. There, negative 0.125. Right? So 125 thousandths. There we go. I don't know what I was saying. 125 thousandths. That's how you read that. Tenths, hundredths, thousandths place. Good grief. Okay, so we are going to plug negative 1/8 back in for x and solve for y. That's one way to do it. We can do the substitution method and solve for y. So that gets a little bit messy. We can also do the elimination method and eliminate our x's and solve for y. It doesn't really matter to me which one you want to do. I'm just going to go ahead and plug this in. So 2, because we are not scared of fractions, times negative 1/8 plus y equals 1. If you are scared of fractions, let's be unscared of them. So we put 2 over 1 and we're going to multiply. So negative 2 over negative 8, and we can reduce to negative 1/4. So I reduced by dividing this by 2 and dividing the denominator by 2 and then multiplying straight across. So negative 1/4 plus y equals 1. Then I'm going to add 1/4 to both sides. And 1 plus 1/4 is 1 1/4. And that's also 1.25. So I came up with, or we came up with, negative 1/8, 1 1/4. And the solution on Desmos was this, and that's the same thing. You can double check with your calculator. Absolutely. All right, we are going to talk about how to set this problem up, and then we will tackle it when I see you again. All right. Solve the system of linear inequalities by graphing. Okay, so we want to define the variables and pick out what we need, okay, what we need from this. So Malcolm's earning money doing chores for neighbors. Okay, we don't really need any of that. All right, but his name is Malcolm, so we can keep that. All right, if you want to keep his name, you can keep his name. His goal is to earn at least $20 per week. So we need that, at least $20 per week. So I'm going to go ahead and circle these numbers in green, okay? All right, but he can only work a max of 20 hours per week. Okay, so I'm going to underline a max and hours per week. Those may come in handy. And then he can spend at least 5 hours per week walking his neighbor's dogs. For how many hours should Malcolm work at each job in order to meet his goals? All right. So let's see about these equations. So I need to define my variables. So we are going to let x be and y be two different things. So I'll give you a second to kind of look at that, and then we'll see what two things he has going on. All right, so the two things Malcolm has going on is he's working, let's see, he's walking dogs, and he's doing some other chore, right? Not really sure what this other chore is because I don't think it says. But he's making $20 an hour doing something, right? For his neighbor. All right, so maybe mowing the yard. We'll just say he's mowing. My pen's not going right. All right, so we'll just say he's mowing 20 hours a week. Okay, so let's write an equation for that in just a second. So let's say X is the number of hours he spends mowing. And we'll say this is mowing. And then Y is the number of hours he spends per week walking the neighbor's dog. And we could have said number of hours for other chores. Like if you don't want to give it something, we know he's going to spend 5 hours walking the dog, and then we'll just say X is doing other chores. Mowing, cleaning up trash, cleaning windows, whatever they need done. All right, so what else did he say? He has to spend at least 5 hours per week walking the dog, so we got that one. All right. So let's see what we got here. So $200 per week is what he wants to earn, right? So let's see. There's a picture that didn't come off on here. He gets $20 an hour for other chores, like mowing, cleaning windows, several chores. And he gets $10 per hour walking the dogs. All right, so that's on a picture that didn't come off on this. That's additional information that you need. All right, so I want to put all the money together. All right, so do you see we have money? We have at least $200 per week, and he's going to make these things $200 on other chores and $20 an hour on other chores, $10 an hour on walking dogs. All right, so I want to put all three of those together because they're all money. I know other chores variable is X, walking dogs is Y. So 20X plus 10Y at least 200 means this stuff has to be greater than or equal to 200. All right, we also know that he can work a max of 20 hours. X and Y are the number of hours he's doing these chores. So X plus Y, a max of 20 means he can't go over 20, so that has to be less than or equal to 20. And then he has to walk the dogs at least 5 hours a week. So Y has to be greater than or equal to 5. All right, so the next thing we want to do is graph these. And so we can graph these by using X and Y intercepts. All right, and we know this is a horizontal line, but we want to think about these as 20X plus 10Y equals 200, X plus Y equals 20, and Y equals 5. So we want to graph those three equations and then choose test points to decide where to shade. All right, so just a reminder. All right, so we are going to, let's count by 5s, going both directions. All right. So this is the number of hours for other chores. And this is number of hours walking the dog. And I know this because of the variables that we defined in the beginning. All right, so I'm going to make this first graph green. So x-intercepts. For an x-intercept, I plug in 0 for y. So this is gone. So I'm left with 20x equals 200. Divide both sides by 20, and x equals 10. So I go to the x-axis, and that's my x-intercept, 10, 0. All right, now I'm going to find the y-intercept. So I'm going to plug in 0 for x. Plugging in 0 for x is going to knock this out. And so I have 10y equals 200, or y is 20. So I'm going to go ahead and plot that point because that's on my y-axis. So notice I plotted these individually. I did not put them together because I plugged in 0 and found the number. So 0 has to go in for the variable that I plugged 0 in for. All right, so I'm going to graph this. These are solid lines because there was a line underneath the inequality. And now I'm going to pick a test point to shade. All right, so I'm plugging back into this, and I love to plug in 0, 0. When I plug in the test point, if it's true, I'm going to shade to cover that area. So 0, 0 is here. I'm going to shade on this side of the line. If it's false, I'm going to shade on the other side of the line. So I'm going to plug in 0, 0. So 20 times 0 plus 10 times 0 is greater than or equal to 200. 0 is bigger than or equal to 200. That is absolutely not true. So we will not shade this way. We're going to shade this direction. All right, so now I know my solution set has to be a point somewhere over here. All right, next line. We're going to graph x plus y equals 20. So I'm going to plug in 0 for x and find y, plug in 0 for y and find x. When I do that, I get 20 and 20, right? I plug in 0 for x, y is 20. I plug in 0 for y, x is 20. But remember, I plugged in 0 for those things. So when I plug in 0 for y, I got 20 for x. And when I plugged in 0 for x, I got 20 for y. So I plotted those points. I'm going to connect them with a semi-straight line. And then I'm going to plug in my test point of 0, 0 because the line doesn't go through 0, 0. You can plug in any test point you want as long as it's not on the line. So I'm going back over here. 0, right? Both of these would be 0. 0 plus 0 is less than 20. True or false? Is 0 smaller than 20? Yeah, it is. So I'm shading on this side of the line. Well, what's already been shaded? The green, correct? So now I know that I'm in this area because it has been shaded green and blue. So when I've graphed two lines and shaded, I want the shading that's common to both. Now I'm going to get the third line, then I want the shading that's common to all three. So y equals 5. Y equals 5 is a horizontal line, right? And I want numbers that are bigger than 5. So that would be above the purple line. So 3 times it's been shaded right here in this area, right? Above 5. So right there, above 5. I think I went below it a little bit. See if it'll. Yep. So this little triangular piece from here to that intersection point and that intersection point, that's where my graph has been shaded. So any point in that region is a solution. All right, so the test points, I chose 0, 0 the whole time. If your graph goes through 0, 0, then you'll have to choose something else. All right, so you plug in 0, 0 and check to see where that shading is. All right, we'll do some more when I see you soon. Make sure you write down your questions. Bye, guys.